So today we are going to look at Leetcode problem 1423, and the problem statement is finding maximum points you can obtain from given cards. So here you are given two inputs. One is an array of cards, and you are also given k, which is an integer. So for each of the card in this array of cards, there is an associated point or a score with that card, and you have been asked to draw k cards from this array of cards that are given to you, such that you should get the maximum score. So you should try to maximize the score when you are trying to pick k cards from the given list of cards. And if you see the constraints that are given here, basically you can have minimum one card, or at max you can have 10 raised to 5 cards. For each of the card, the score can be between minimum 1 and 10 raised to 4. And also the number of cards that you have been asked to draw will be between 1 and the maximum number of cards that are available. Now there is also a constraint on this problem where while picking k cards from given list of cards, you can pick the cards in this array in such a way that you can either pick from the beginning or from the end. So that is one of the constraint that has been put on this problem. So now let's look at how to go about solving this problem with the necessary constraints that are defined for this problem. So if you follow the constraints with respect to picking the card, then you can either pick this card first, or you can either pick this card first. Now let's see what happens if you try to pick in any of that, right? So as I said, there are two choices when you pick the card for this array. So you can either pick one on this leftmost side, or you can pick one on the rightmost side. So these are OR. Let's say if you pick one, then on the left side, then you have this as the remaining array. So again, you have to follow the same constraint. You have to adhere to the same constraint when it comes to picking the next card. You can now either pick the leftmost or the rightmost. So in this case, again, you can either pick 2 or you can pick 1. So let's say now after you picked 1 and now you pick 2 from the left side, you have this remaining. So you can again pick 3 or you can pick 1. So let's put that, and again pick 3 or you can pick 1. And now since k is 3, we have already picked 3 numbers here, 1, 2 and 3, which is 1, 2 and 3 in this case. So we have to stop. We cannot go any further. So this is one possibility. 1, 2, 3 is one possibility that you can pick. Now if you look at this other possibility, you can also pick 1, 2 and 1, which is basically 1, 2 here, and the 1 on the rightmost side, which signifies this path, 1, 2 and 1. I'll just write it here. Similarly, if you follow the other paths, all the other paths, let's take an example of this. So you picked 1 from the left first, then you instead of picking 2 from the remaining, you can very well pick 1 from the end. So we did pick 1 from the end here. So in this case we picked this, and now we picked this as well, and we have this as the remaining array of cards to choose from. So in this case you can again pick either 2 or 6, which is 2 or 6. So in this case, if you see, this path signifies 1, 2, 3, which is 1, 2, 3. The second path 1, 2, 1 signifies 1, 2 and 1. The third path signifies 1, 1 and 2, which is 1, 1 and 2, which is same as 1 to 1. So these two are same. So although the order may not be same, but from the fact that the scores of each of these are the same. So if you pick 1, 2 and 1, or you pick 1, 1 and 2, basically if you try to sum those, which is what we are looking for, a maximum score, then the scores of both are going to be the same. So basically it doesn't matter, the order doesn't matter, right? But this is just for depiction purpose, as to if you explore this tree, you will come to know all the leaf nodes basically are signifying the combinations of card that you picked, and each of them will have a score associated, and now you have to find the one with the maximum score. So that is the basic idea. So now you're basically looking at a tree which is fully expanded, and it is listing all the possibilities for k is equal to 3 for this array. So if you see, the leaf nodes, uh, in this case, let's go step by step. So in the first pick, there is a possibility that you may pick 1 followed by 2 followed by 3, which is listed here. There is also a possibility you may pick 1, 2 and followed by 2. Instead of picking 3, you may pick 1. So that is 1, 2 and 1, which is listed here. Similarly, you can pick 1 and then instead of picking 2, you can go to 1 and then pick 2. So your order will be 1, 1 and 2, which is listed here, and so on and so forth. So if you see 1, 1 and 6, and then 1, 1 and 2, 1, 1 and 6, 1, 6 and 1, and 1, 6 and 5. So basically, you might have got an understanding of how you can go about choosing and picking particular cards depending upon what is remaining. Now, one point to note here is a lot of, even the order in which you pick the cards differs, but based on if you pick the same cards which were picked earlier in some other order, you will end up with the same score or same point, which is depicted here in these two sets. So basically, whether you pick 1, 2, 1 or 1, 1, 2 or 1, 1, 2, either from left or right side, they all will have the same point. And similarly, if you choose 1, 1, 6 or 1, 1, 6 or maybe 1, 6, 1, they will again have the same score. So this is one observation that you want to keep in mind. So one more observation you can make from this is, so if you map these things to scores, then you are getting finally from all these possibilities, you are getting 4 different scores, right? One is from 1 to 3 by choosing and picking 1, 2, 3. That will be your first score. Then for all these 3 combinations, you will get 1 score. That is your second score. Then all the other 3, you are going to get the third score. And for the fourth, you will get the fourth score. So you have 4 scores. That is a critical observation you have to make. Now, based on the observation that we have made earlier, let's look at how these cards that are picked in this order, they map to this array. So in this case, if you see, let's look at this first choosing, which is 1, 2 and 3, 1, 2 and 3. This particular combination maps to the first 3 elements from the leftmost side. Now let's look at the second. So all these 3, 1, 2, 1, 1, 1, 2 and 1, 1, 2, as I mentioned earlier, whether it is 1, 2, 1, whether it is 1, 1, 2, or whether it is 1, 1, 2, they all map to these 2 elements on the left and 1 on the right. Similarly, if you see this third combination, 1, 1, 6, 1, 1, 6 and 1, 6, 1, which is 1, 1, 6, 1, 1, 6 and 1, 6, 1, they all again map to 1 element on the left most side and 2 elements on the right. And finally 1, 6, 5. So there is only 1. So this maps to the rightmost, which is 1, 6, 5, which is again 3 elements on the rightmost and 0 element on the left. Now let's look at how each of these 4 score map to this array. So let's take this first one, 1, 2, 3. So if you see, this is mapping to the leftmost 3 elements. The second score, 1 to 1 and all these 3, which results in the same score, they map to 2 elements on the left, which is 1, 2 and 1 element on the right. The third score again matches to 1 element on the left. I have not shown it here, but you can observe that 116 matches to 1 element on the left and 2 elements on the right. And the last one, 165, basically maps to the 3 rightmost elements. Basically what is happening here is, if you observe, you have a sliding window of size k is equal to 3, and you are sliding that window on the left, and in the process you are dropping the rightmost element in that window, and you are including the rightmost element in the array as a part of the new window. And that is what you are doing. So basically, if you start here as an example, you have all these three leftmost element, you find the sum, you'll come to know what is the point, and you store that point. Then you slide this window and drop 3, and at the same time you include 1 from the rightmost side. Then you again calculate the points for this new window, which is 1, 2 and 1, and find out whether that is the max or not. Then you slide this window further and exclude 2 from that window, and now include the new number 6 on the rightmost side. So you will have 1, 1 and 6, and find the point again. And then finally you slide this window one last time, and you have no elements from the rightmost side in the window, and you have all these 3 elements here, which are the rightmost elements of the array, and you try to find the points. And in the process, for all the windows, whether it is this or all 3, you found the points, and now you need to basically find the maximum points among all of that. So that is the crux of this particular problem. If you understand this particular part of the algorithm, it becomes easy for you to solve this or implement this in an interview.